Okay, good morning, everyone. Hopefully everybody's doing fine. It's Monday morning, and I am gonna make a short video here on just the basics of exponents, which is what chapter 10 is about. So this is all kind of review. I mean, I don't know, you probably saw it first in fourth grade, I'm guessing, maybe later. But yeah, it's tricky stuff. So, and I really recommend you look at the book, like the actual writing in it, not just the problems. I mean, he does lots of examples, talks about stuff. It's very helpful. Since we don't have class now, really look at the book more for examples and the rules. I'm going to go over some of the basic stuff here, and then hope that between what you've seen before, you can do this stuff. The beginning problems are all just like calculator problems and using the rules for exponents, which can get pretty tricky. So, okay, so first, like the rules that they go over. First off, one is you've probably seen before. I think most of you guys are pretty good at this, but like if you have the fourth root of something, right, you put a 4 there, then that just means that that's whatever is here, whatever that number is, call it b, that's just to the 1/4 power, right? That's what that means. That number there is to the 1/4 power. So that's not so crazy. You guys have seen that before. Now it gets a little bit crazy. Let's say we had the fourth root of b to the third. And so that would just be b to the third is b to the third. That's 1/4. So that's b to the 3/4, because of 1/4 in the bottom, and it's so b cubed to the 4th power. B cubed to the 1/4 power. So if we do an example, let's do like we have 27 to the 4/3. What that means is there's two ways to do it. We can usually it's easier to do the third root first and then take that to the 4th power. So we take the third root of 27. What times itself 3 times is 27. So that's 3 times 3 times 3. So that's 3. So that would be 3 to the 4th power, which is then 3 times 3 times 3 times 3, which is 81. So it's usually easy to take the root first and then raise that to the 4th power. Okay, so that's just that whole root thing, which again can be pretty tricky. So just be careful of that. There's applications always get tricky. Okay, then all the other standard rules. If you have, and I'm using the letters I use in the book, if you have a number to the r power times the same number to the s power, then all you do is you add exponents. So b to the r plus s. So for instance, if we have 3 squared times 3 to the 5th, how many 3's do we have? We have 2 here and we have 5 there, so you add them, you have 3 to the 7th. So you have 3 3's. It's always good to use a simple example of numbers and see, oh yeah, that makes sense. You just add how many 3's you have, you add them together. So that's the product rule. Then if we have a power to power, like we have b to the r to the s power, then you multiply. So that's b to the r times s. So for example, if we have 2 cubed to the 4th power, and again, it should make sense. That means we have 2 cubed times 2 cubed times 2 cubed times 2 cubed, which how many of those do we have? We have 3, 6, 9, 12. So we have 2 to the 12th, which again is just multiply power. So again, if you're wondering about how the rule works, it makes sense that you multiply. You have 4 2 cubes. So you add them all up, 4 of them is 12. So you get to the 12th. Okay. Then, if you have 2 things to a power, you raise each one to the power. So that's a to the r times b to the r. You raise each one. So, for example, if we have 2 pi to the 3rd power, that's 2 to the 3rd power, which is 2 times 2 times 2, which is 8. Times pi to the 3rd power, which just leave it as like that. So each one you cube, which again, if you wrote it out, it should make sense. That's 2 pi times 2 pi times 2 pi, because we have 3 of those, right? So 2 times 2 times 2 is 8, so of course that's 8 pi cubed. It always helps to come up with easy examples and do that and go, okay, yeah, makes sense, because these rules can get tricky. Okay, then of course, anything to the 0 power is 1. That comes up a whole lot. That's always an awesome rule, because ones are always nice. And then lastly, if you have a negative power, that just means 1 over that, right? With negative powers means they're in the denominator, so you just put it like that. And that comes up a whole lot, and that can get kind of tricky too. So 1 over BDR. Yeah. Okay. Let's do some more examples then. So let's say we have, okay, here's another thing. Exponents, we're going to use this a lot. For exponential growth, which you've probably heard a lot about these days because of the whole coronavirus thing, has exponential growth. So what that means, you can always write exponential growth as the amount of something. So they usually use the letter A for the amount. The amount of something is the amount you had at time 0. So you put a little 0 there for time 0, how much you started off with, times some base to the t power, to the time up here. And it could be x, whatever variable you want to use. But if we're using time, which often it is, you put a t up there. So how much you have at any time depends on how much you start off with, times some base to the t power. Okay, that's like the standard exponential form that they talk a lot. So if we want to write things in that form, some other thing, then you have to use all these rules to do that. So for example, let's say we want to write 4 to the 2x in standard form. Okay, so and again, x is like t. So we want to get some base to the x power. So what you do is you use the rules. That would be the same thing as 4 squared to the x power, because remember you multiply power, so 2x would be to the 2x. So you can always put that to a power. And 4 squared, I know what that is. So that's 16. So that's 16 to the x power. And that would be standard exponential form where a0 is 1. So we have the base 16 to the x power and a0 is 1. Okay, so how about this? Let's do 4 to the 3x plus 2. Write that in standard form. Okay, so again, when you have a plus there, it's multiplied. So that would be 4 to the 3x times 4 to the 2. Because again, the rule is you have the same base, add when we get 3x plus 2, which we go back to here. 4 squared is 16. I'm going to put that in front as the a0. So 16 times, just like we did before, this is 4 to the 3rd to the x. Okay, and then, so now 4 to the 3rd, okay, that's a little bit tricky. 4 times 4 is 16 times 4 is 64. So that's the same thing as 16 times 64 to the x power, which is in standard exponential form. So that works out pretty well. Okay, so that's what a lot of these problems are going to be like. I'm going to do one more example, and then I'll make another video doing some more like the problems that they have. But this is just the basic stuff. This is all in the book. Again, I suggest you kind of read that, do some of the practice with that. Okay, let's do a trickier one. Let's say we have 3 times 1/3 to the negative 3x minus 1. And we want to write that in standard exponential form. Yikes. Okay, so that's the same thing as 3 times 1/3 to the negative 3 to the x. So I'm going to do this whole thing, negative 3 to the x times 1/3 to the negative 1. And again, so that would be negative multiply, so negative 3x, 1/3 times 1, can you add them together, so negative 3x minus 1. Okay, I think I did that right. Well, let's see. That looks pretty terrible, but actually it's pretty good. So this negative power means, so this is 3 times, in the parentheses here, we have 1/3 to the negative power, which means you flip that upside down. 1/3 upside down is 3, and then that's just to the third, because a negative just takes a fraction upside down. That's to the x power. And 1/3 to the -1. -1 just means you flip it upside down again. You put the denominator up here, the numerator in the bottom. So that is just 3. So the final answer to that in standard exponential form would be 3 times 3, which is 9. 3 times 3 times 3, which is 27. So 9 times 27 to the x. So our a0 is 9, and our base is 27, and we raise that to the x power. So then this is in the form again, a0b to the x. So that's the whole standard exponential form thing, which is what the first problems are all about. They're tricky, but they're really good practice. And I'll make another video doing one of the more longer word problems to help you out with that. Hopefully the audio is a lot better. I'm using my cell phone now, not the document camera, which I think has much better audio. So hopefully this one is more pleasant to listen to. All right. Thanks for listening, guys. I'll see you in the next video.